Okay, so what I want to do now is I want to show you how this project works. So what I'm going to do is I'm going to tell the alarm to go off at a certain time, and then I'll show you what happens when the alarm goes off, how to turn it off, and the other features that are included in this project. Okay, so what we're going to do now is we're going to set the alarm to start to go off at 7:03, and the actual buzzer will start beeping at around 7:20. And then we'll demonstrate what happens then. So the wait time over here is 240,000 milliseconds, which equates to about 6 minutes. And so the time the program was started was at 6:57. The alarm is going to start going off at 7:03, which is the right time. Okay, so by switching this right here, the first button, to on, the on position, what we can do is we can turn on the red light right here. And then once we switch this back into its original position, it turns off. So this basically means that we can turn on the red light on at night whenever it's necessary. Okay, so the alarm should be going off pretty soon now. And if we look at the time, it's almost 7:03. So any second now the alarm should be turning on. So let's just wait. Oh, there we go, it just turned on. And as you can see, the time right now is 7:03. And so yeah, so now over time what's going to happen is it's starting off pretty light right now. But over time it's going to get even brighter and brighter. So it's going to so this value right here now is 1, and every 4 seconds it's going to increment the value by 1. So after approximately 17 to 18 minutes it will reach 255, which is the max brightness. And from there we can actually start up the temperature, showing the temperatures through the colors, and turn on the buzzer. Also, now that the alarm is activated, switching switch 1 to the on position won't do anything because the alarm is activated, and thus the red light can't be turned on because the light is currently being used. The alarm just went off, and what I had to do is in my previous shot, the buzzer was too loud and you couldn't hear my voice. So all the previous shots I took were yesterday, but today is the 13th. So now I'm going to demonstrate how this works. So what I'm going to do is when I flip pin 3 up on the button 3 up, the button will turn off, but the alarm will still be activated. So as you can see right now. And then the problem is this button doesn't go into the breadboard properly, so I had to push it down sort of. But I can just get it right in. Okay, so anyway. So now that the thing is, the buzzer is off, but the alarm is still going on. So as you can see, it's it is still cycling through to all the temperatures of the day. So green means it's a comfortable temperature, blue means it's gonna be, oh, this is just all lights on to make it awake. And then we might have a hot temperature since it's near the 80s today. But yeah, so that's how this works. And then if I turn the buzzer 3 back down, what you can see is the alarm turns back on. Now, the way I would activate this is here, I'm going to turn buzzer 3 back off actually now. Yeah, so if I want to turn the alarm off now, what I would do is, since today is the 13th, I'd have to use the last 5 buttons to create a binary combination that would equal the 13th. So in this case, it would be 1101, because that would be 8 plus 4 plus 1. That would be 13. So right here, let me just turn this light on. Buttons 5 and 6 are already turned on, so that's 8 plus 4. And then what I'll do is I'll turn up this last one. Actually, I'll turn this buzzer on so you can physically hear when it. So yeah, so now button 3 down. Okay, yeah. So now you can hear when I'm going to turn the alarm off. So all I'll do is I'll put button 8 up, and you can see now the buzzer is turned off and the LED alarm has stopped switching. So the LED alarm is going to turn itself off after 2 minutes, and then the particle photon will wait for another day before activating again. So now 2 minutes have passed by, so the alarm has turned off, and once again by switching switch 1 on and off, I can basically control when the red light is on or off. So once again I can do that again because the alarm is no longer activated. And also I'd like to tell you about another feature I implemented here. So basically, if I'm ever on a trip or anything, or I just want to wake up early one day, all I had to do is just flip switch 2 on here. Let me just turn on this light. I just flip switch 2 up, and what that would do is it will disable the alarm from ever activating. So that would mean that the particle would just not even turn on the buzzer or the LED that day. But let's just say I'm on a trip and I forget to do this. So the alarm is still going to go off. And of course, if I'm on a trip, I might not be at my home for days or anything. And I wouldn't want the alarm and the buzzer to be going on incessantly. So what I would do is I baked in a feature in here in the program. So basically what happens is after 10 minutes of the alarm going off, it'll turn itself off. So the alarm will activate for 10 minutes, and if I don't do anything, then of course it'll turn itself off. So this is really useful, because 10 minutes is the time where of course I'm not going to spend 10 minutes listening to the annoying buzzer. So it's just enough time that I'll be able to wake up, but it also is short enough that it won't be going on forever basically until I come back home. So this allows for sort of flexibility, so that it can turn itself off when necessary, but still wake me up. And so this balance is really nice because it also saves power and can stop my neighbors from getting annoyed. Alright, so what I'm doing right now is I'm shooting a time lapse to demonstrate that the LED alarm will turn itself off after 10 minutes. But I'd also like to point out that the buzzer has 3 different tones that it cycles through. And also these tones are generated by random. Only one tone is actually predefined, and the others are just defined by random values. So sort of like every tone is unique, and it just provides sort of it feels like one big tone. And the nice thing about this is just to have a little variety, because I think it would just get a bit boring to listen to the same tone over and over again. Now originally I had 10 tones, but the problem was, here, let me just turn this off so you'll be able to hear this better. Then I need to make the button go in the right place. Alright, so the advantage, so originally I was going to have 10 tones, but the problem was, so when I'm in my code, I'm storing 3 arrays. So one array is for how long you should keep the buzzer on, the next one is how long you keep it off, and the third array is for the actual value for which you're gonna, like the actual tone you're gonna keep the buzzer on, sort of like PWM. You control the tone of the buzzer. The problem was, originally when I was doing this on Arduino Pro, didn't have enough memory because each of these arrays was quite a few. I think it was 10. I think it was 10 tones each. 10 values per array, and then times 3. So 30 integer values per tone. So obviously, if I have 10 different types of tones, that would be 30 times 10, which is 300 integer values. And Arduino just didn't have enough memory to do that. So to save memory, I just had to downgrade all the way down to 3 tones, which is 90 integer values. Which is still pretty good because to get around that problem, I generated random numbers for the tone. So each tone still feels a bit unique, so that's really nice as well. So yeah, I just wanted to, so I'm going to turn the buzzer back on now so you can just listen and try to see if you can notice the 3 different tones. Right, and finally, I'd like to also mention that the 3 tones actually also are chosen at random. So it isn't like a sequential thing where it's like first play tone 1, then tone 2, then tone 3. It's sort of like random, so it'll be like tone 1, tone 3, tone 2, tone 1 again, then tone 2, then tone 1 again, then tone 3, then tone 3 again. So also that adds a bit more variety. And I think it just is more effective at waking me up. So yeah.